Working on lesson 3.1, which is the quadratic functions, graphing quadratic functions in both factored form and vertex form. So let's first of all look at the parent quadratic function, which is the most basic function, y equals x to the power 2. Now, in order to be graphing this, let's go ahead and plot this in our calculator. So y equals x to the power 2. And then go to graph. So as you can see, the quadratic function looks like a parabola, a U shape. Now let's go ahead and go into the table. And the most important point in a quadratic function is the vertex. So let's go to the table and figure out where the vertex is. Now the vertex is the point where everything else around it is symmetrical. So in this case, if you look closer at the table, 0, 0, we have 1 above, 1 below, 4 above, 4 below, 9 above, 9 below, 16 above, 16 below, and so on. So then in this case, my vertex is 0, 0. So that's the most important point, and let's put it in the, or halfway in our table. And let's plot it on our graph. Now, let's go ahead and get some points that can be plotted in our graph. So negative 1, 1, 1, 1, negative 2, 4, 2, 4, negative 3, 9, and 3, 9. Now let's plot these points. So as you can see, all the points are symmetrical. Once I plot the points, I connect the points, and that's going to be my U shape. And remember, the most important point is my vertex, which is at 0, 0. And it's the point where everything else is symmetrical around it. You see that? 1, 4, 9, 1, 4, 9. So let's go ahead and answer some of these questions. The y-intercept is the point where the x is 0. I can look at the table over here and I can see when x equals 0, y equals 0. So that's my y-intercept. Or I can look at the graph and ask myself, where did the graph touch the x or the y-axis? This is the y-axis. The graph touched the y-axis at 0, 0, so that's my y-intercept. In this case, my x-intercept is the same. It's 0, 0. It's the origin. It's the vertex at the same time. And that's why it's called the parent function. It's the most basic function. And again, my parabola intersects the x-axis at what point, and that's going to be the x-intercept. And remember then in this case, the root and the 0 and the x-intercept mean the same thing. So x equals 0 would be my root. Now, what is the axis of symmetry? The axis of symmetry is a line. It's a vertical line that cuts my parabola in half. So basically, it's a vertical line that goes through the vertex. Since the vertex is where everything else around it is symmetrical. And the equation of this axis of symmetry is going to be x equals 0, since it crosses the vertex. So it's going to have the same x value as the vertex. The x of the vertex is 0. So x equals 0 is going to be my axis of symmetry. It's a vertical line, and that's the equation of this vertical line. Now look at the vertex. Is this a maximum or a minimum point? Now, if it's the lowest point in my graph, then it's called a minimum. If it's the highest point in my graph, then it's going to be called a maximum. So it's a minimum at 0 since it's the lowest point. Now, what's the domain of this graph? If you can see, this graph continues on forever to the left, forever to the right. So the domain of a quadratic function is always negative infinity to infinity. The range is from bottom to top. So the lowest point is the vertex, so the range starts from y equals 0. And then it continues on forever, so it's from 0 to infinity. Now, what are the three other names for x-intercepts? Like we said before, an x-intercept is the root, is a 0, and a solution. So if I ask you what's the 0, what's the root, and what's the solution, I mean the same thing in this case. It's the x-intercept. Now, what's the name of the point where the y value of the function changes direction? It means like this graph, when you're graphing it, you're not continuing on like that. You're changing direction and going up. So you go down, and then there's the vertex, and then you go up. This is how you graph it. So the vertex is where the function's changing direction. So this is the parent function. I can always plug in the equation y equals, and then I can go to the graph to see how it looks. I can then click second graph. I can go to the table, find the vertex and all the important points I want. Now, today we're going to be seeing this quadratic function in two different forms, in the vertex form and the factored form. What is the vertex form? Y equals a, x minus h to the power 2 plus k. This reminds us of the absolute value function, right? So the vertex is always hk. What does a represent? Remember what we said? If a is positive, then your graph opens upward. If a is negative, then your graph opens downward. It's just like the V shape, the absolute value, same concept. How do you find the x-intercept? How do you find the y-intercept? We're going to talk about that in details in the questions that will follow. Now let's look at the factored form. This is the equation of the factored form. Now a, x minus, and there will be a number over here, and x minus, and there will be a number over here. So for example, if this is 2 and this is 3, then my roots are going to be R1 and R2, okay? Again, we're going to talk about this in details later on. Now, how do you find the vertex? We will find out too. Now, we will go back to this at the end of the lesson to answer all of the questions. Now, let's move on to our notes. And remember, it's the white paper. It should say academic. This is how you can tell this is your notes. Now let's move on to our first example. Y equals negative x minus 2 to the power 2 plus 4. Now let's go ahead and answer what a, h, and k are. And we can always check by graphing this. But remember that the a is always the number in front. So in this case, it's negative 1. Since a is negative, keep in mind that this graph is going to be opening downward. We will see that on the graph in a minute. The h is going to be opposite of the number on the inside, so it's going to be 2. And the k is going to be also the number on the outside, so that's 4. My vertex is h comma k. So in this case, my vertex is 2 comma 4. So let me plot that. Okay. Now, how can I find all of this from my graph? So let me go to my graph, clear that. So negative and then negative, open parentheses, x minus 2 to the power 2, and then move over. What did I do? Let me delete that. Okay, so 2, and then move over, plus 4. Okay, let's graph it. So let me make this smaller so you can see a better graph. Okay, now as you can see, it's opening downward, but I already know that since the a is negative, so it's always good to graph it on your calculator to double check. Now let's go to the table and see how can I know what the vertex is from the table. I need to look for a point where everything around it is symmetrical. So let me look. Okay, let me make this go down a little bit. Okay, so do you see a point where everything around it is symmetrical? As you can see, 2, 4 in this case is my vertex. So if you look above the 4, you have 3, 0, negative 5, negative 12. And below the 4 also you have 3, 0, negative 5, negative 12. So 2, 4 is my vertex. Everything around it is symmetrical. Okay? But I already know that. You can look at the equation, always take the opposite of the number on the inside and the number on the outside, so 2, 4. You can tell from the equation or you can tell from the table. It's up to you, it's your decision. Now, is this a minimum or a maximum? Let's look at the graph one more time. In this case, the graph is the highest point in my parabola. So it's a maximum, it's the highest point. So let's write that down. And let's go to our table. So it's a maximum, it's the highest point, right? Highest point in my parabola. Now let's go to the table and get some points that I can graph. So -2, -12 is not gonna fit in my graph. So I'm gonna take some points. Always take the vertex and put it in halfway in the table. And then we have 1, 3, maybe 0, 0, and then 3, 3, 4, 0, and so on. Okay, now let's plot these points. So we have 2, 4, we have 0, 0, we have 1, 3, we have 2, 4, then we have 3, 3, and then we have 4, 0. Is there anything else that's going to fit? Yeah. We have -1, -5. So let's do that. And then there's another point that's going to fit, which is 5, -5. So let me write that down also. So as many points, so your graph is going to be accurate, okay? So that's going to be my graph opening downward since A is negative. The number in front is negative, okay? Now, how can I find the y-intercept? The y-intercept is the point where the graph touches the y-axis. And as you can see, my graph touches the y-axis at this point, and it's the origin, 0, 0. The x-intercept is where your graph touches the x-axis. So this is the x-axis. My graph touches the x-axis in 2 different places. It's 0, 0, and 4, 0. Now you can tell from the graph, or you can go back to your calculator. You look for a point where y is 0. When y is 0, x is 0. That's my x-intercept. And there's another point. When y is 0, x is 4. So that's my second x-intercept. To find the y-intercept, you look for a point where the x is 0. Y is 0. So that's my y-intercept as well. In this case, the x-intercept and the y-intercept are the same. Now remember, the roots, zeros, and x-intercept mean the same thing in this case. So x equals 0 and x equals 4 would be my roots. The domain is going to be from -infinity to infinity always, since this is going to continue on forever, to the left and to the right. Domain is from left to right. Range is from bottom to top. This is going to continue on forever down, so that's going to be -infinity, all the way up to the y, in this case, which is a 4. And you can depend on the graph to tell, or you can just look at the equation. This number will give you the range. It's the y of the vertex. The y of the vertex. Now this is one of the graphs. Now go ahead and try to do this next example on your own, and the next example is going to be this. So let me turn the page, and let's go ahead and do this one together. The second example is an example of a root form. It's called factored or root form because you can get the root from the equation. If I look closer at the first factor, I can tell that my root is 3. And if I look at the second factor, I can tell that the root is -1. How can I find the roots? I just set the factor equal to 0 and I solve for x. So let's do the first example. If you said that the first factor, x minus 3 equal to 0, you can solve for x, and you get that x is equal to 3. Or you can simply take the opposite of the inside number. So then the roots are 3 and -1. This is one way for you to find the roots. And remember that the roots are going to be numbers on the x-axis. They are the x-intercepts. Now definitely there's another way for you to find the roots, and that is by plugging the equation into y equals, and then going to the table and look for an x value where y is equal to 0. Now let's graph it. Now I can tell that -1 and 3 are my roots, or I can just go to the table and I look for numbers or x values where the y is equal to 0. So -1 has a y of 0, so that is my x-intercept. Another x-intercept is 3 because the y is 0. So my two x-intercepts or roots are -1 and 3. Now I can tell that the y-intercept is 0, -6. So a y-intercept is a y value having an x equals 0. So this is my y-intercept. Now let's find the vertex. The vertex is the point where everything around it, just as you can see, is symmetrical. So -6, 0, 10, -6, 0, 10. So in this case, the vertex is y, or 1, -8. So let's go ahead and start doing that. So 1, -8 is going to be my vertex. So that's the vertex. And now let's create a table of y and x values to be able to graph the points. So -2, 10 can fit on my graph. -1, 0, 0, -6. Then I'll have more x and y values, so more points. 3, 0, and 4, 10. Now let's go ahead and plot these points. After you plot the points, connect the points, and this is your parabola. As you can see, it's pointing upward, and I can already know that because the A is positive, so it points upward. The y vertex is the lowest point, so that's a minimum. And the vertex is, in this case, 1, -8. Okay, now y-intercept, we said it's 0, -6. Now let's look at the graph and see if it makes sense. Did the graph touch the y-axis at -6? The answer is yes. So 0, -6 is my y-intercept. The x-intercepts are the points where the graph touches the x-axis, and as you can see, we have two of them. The first one is going to be -1, 0, and the second one is 3, 0. And the roots and the zeros are the same as the x-intercept, so x equals -1 and x equals 3 are my two roots. But I already know that from before. Now the domain is -infinity to infinity, since this graph continues on forever on the left and the right. The range starts from the bottom, from the lowest point, from the vertex, the y of the vertex, all the way to plus infinity. And that's our second example. Now take some time and do the third problem. This form is the vertex form. It's called the vertex form because you can get the vertex from the equation. A in this case is 2. It's the number in front, so that's a 2. Since it's positive, then I know my parabola is something that opens upward. The h is the opposite of the number on the inside, and k is the number that's on the outside. So as you can see, my vertex is -2, -2. I can tell all of that from the equation alone. Now, since this is going to point upward, the vertex is going to be a minimum. Now let's check if I did all of this correctly, and I'm going to go to the table and double check. I'm going to start by going to y equals, and I'm going to clear that and put my new function. Then I'm going to graph it. Now I can tell that the graph is pointing upward, and I know that because the a is positive. The vertex is a minimum. Now if I go to the table, I can double check that. So second graph to go to the table. Now let's find the vertex, or the point where everything around it just repeats. So 0, 6, 16, 0, 6, 16. So my vertex is -2, -2. That's my vertex. Now my x-intercept is the point having a y value of 0. So there's two of those. X equals -3 and x equals -1 are two roots. Now let's find the y-intercept. The y-intercept is the point having an x equals 0. So that's going to be my y-intercept. So let me create a table of values. So -4, 6 is going to be my first point over here. -3, 0 is over here. -2, -2. -1, 0, and 0, 6. Now let's connect the points, and that would be my parabola. Now let's answer all of the other questions. What is the y-intercept? The y-intercept is the point having an x equals 0. Or basically, it's wherever the graph touches the y-axis. That is my y-intercept. My x-intercept are -3, 0, and -1, 0. As you can see, we have two x-intercepts. I have two roots, and they are the x-intercepts. The domain is -infinity to infinity as usual, and the range is going to be from the bottom all the way up. And in this case, the range is going to go from -2 to infinity. Now that's the third example. Now let's go back to the questions and try to answer them together. How do you find the vertex? You go to second graph. So first of all, you go to y equals, put the equation y equals, then you go to second graph to get to the table. You look at all the points and find that point where everything around it just is symmetrical, and that would be your vertex. How do you find your x-intercept? You go to the table, and the x-intercept is the point having a y of a 0. How do you find your y-intercept? Again, you go to your table, and the y-intercept is the point having an x equals to 0. Now that's everything for today's lesson. Make sure that you watch the video again if you need to, and do all the odd numbers on the practice sheet.